So today we'll start with periodic classification of elements. Now, in the olden times, when elements were not discovered, there was no chance of periodic classification of elements. But as more and more elements began to be discovered, what happened is that there were so many elements that studying all of them separately was not possible, and they got mixed up in properties and stuff. So what the scientists decided is that they would classify the elements in some order. Now at present 114 elements are known, and they are classified under the modern periodic table. You might have seen a picture of this modern periodic table in your textbook or somewhere else in your laboratory. So this periodic table is nothing but an organized classification of the elements that are known up till now. But the modern periodic table was not the first attempt to classify these elements. There were several attempts before this periodic table, and the modern periodic table is also not the perfect classification of elements yet. It is said to be the perfect, but still there are discrepancies in the periodicity properties of the elements and all. So what happened is that the scientists tried to find some kind of similarities or some kind of repetition of properties in the elements. So the first person to do this classification was Dobberiner, and he classified them as, there is some 2 dots over here, Dobberiner's triads. Now triads are basically a collection of 3 objects or things, or in this case elements. So he took 3 elements. Let's say he took ABC. I'll tell you what were ABC later. And he observed that the atomic weight of B is roughly, not very, or you should write this equal to the average of atomic weight of A and atomic weight of C. That is atomic weight of A plus atomic weight of C by 2. So this was his formula for classification. Let me write it in a better way. And he found 3 such groups of elements. One was lithium, sodium, potassium. Now the atomic weight, you understand what atomic weight is? The atomic weight is basically, for your understanding, it is equal to the atomic mass. There is a slight difference between them, but till your level you can consider it equal to the atomic mass. And atomic mass is what? It is the number of protons plus neutrons. So basically it's the number of protons and plus the neutrons. So lithium's atomic mass or atomic weight is 6.9. You can consider it as 7 if you want to. Sodium is 23 and potassium is 39. So you see that 6.9 plus 39 by 2 will give you 45.9 by 2, or you can nearly write it as 46 by 2, which is nearly 23. And what is 23? The atomic weight of sodium. See? So he noticed that the average of atomic weights of lithium and potassium is roughly equal to the atomic weight of sodium. So he called this a triad, because of their similarity. So this group is one Dobrynin's triad. Now there are two more groups of three elements, which are calcium, strontium, barium, and chlorine, bromine, iodine. Calcium's atomic weight, you don't need to memorize the atomic weights. 40.1, strontium is 87.6, and barium is 137.3. So if you see, the atomic weight of strontium is roughly the average of atomic weights of calcium and barium. So Dobrynin's formula was that if A, B and C are belonging to the Dobrynin's triad, are a Dobrynin's triad, then atomic weight of B will be equal to atomic weight of A plus atomic weight of C divided by 2. This was his formula. But the disadvantage was that he could find only 3 such triads. I mean, there were more elements discovered at that time than these 3, and now there are even more. So he could find only 3 such triads, so it was not of much use. Although it was the beginning of the classification of elements. So you can get questions like A, B, C. Suppose A, B, C are some hypothetical elements. The atomic weight of A is 15. The atomic weight of C is suppose 45. And the atomic weight of B is 30. So do these form a Dobrynin's triad? So you just put in the formula 45 plus 15 by 2, which is 60 by 2, which is 30. And 30 is the atomic weight of B. So they form a Dobrynin's triad. Very simple questions. Or you can get theoretical questions like, what was the main disadvantage of Dobrynin's triad? So the main disadvantage and there was only one disadvantage, of course, was that he could find only 3 such triads. Frequently asked question, what is the disadvantage? So the answer is he could find only 3 such triads, although more elements were known at that time. And obviously they can ask you an example of Dobrynin's triad. So you can write the simplest ones: lithium, sodium, potassium. Whenever they ask you give an example, always give the easiest example. Don't go for very complicated examples like chlorine, bromine, iodine, or calcium, strontium, barium, because then if you make a mistake, then you might lose marks.